My project title is Structural Strengthening of Reinforced Concrete Beams Using Ferrocement Laminates with Addition of Alccofine. And my project guide is M. Priyadashni ME, Assistant Professor, Department of Structural Engineering, Veritech High-Tech Engineering College. Aim. My project aim is to study the flexural behavior of reinforced concrete beams using ferrocement laminates with addition of Alccofine. My main objective of the project is to design the reinforced concrete beams theoretically and to calculate the load carrying capacity of the beams and to form the sectional properties of the beam as well as the ferrocement laminates and carry out the load carrying capacity of the beam. Then the obtained results are viewed, compared theoretically and experimentally. Introduction. Most of the structures are invariably made of reinforced concrete may fail under due to continuous loading. Due to continuous loading, the structure may fail at a certain point, which can be overcome by strengthening of the beam using retrofitting. Retrofittings may be classified into different techniques. Retrofitting can be done by GFRP, CFRP and ferrocement laminates, etc. Here the strengthening technique is by ferrocement laminates with addition of Alccofine in cement mortar. What do you mean by Alccofine? Alccofine is a specially processed product based on slag of high glass content with high reactivity obtained through process of controlled granulation. Methodology. My project work is classified into two types, phase 1 and phase 2, in which phase 1 consists of literature study and material collection, and phase 2 consists of material testing, theoretical study, experimental study and comparison of results. Summary of literature. Based on the above literature, it has been concluded that the ferrocement laminates has been used for roofing purposes. Normally, largest span depth ratio in flexure, which is shear as well as failure criteria. Alccofine in concrete shows better results than normal RCC. Materials used: cement, fine aggregate, coarse aggregate, Alccofine and welded mesh. The physical properties of cement are given in the table as shown here. The physical properties of fine aggregate as shown in the table. Physical properties of coarse aggregate are shown here, which has a specific gravity of 2.65 and fineness modulus of 7.07. Physical and chemical properties of Alccofine. These properties has been tabulated by the material products, which has a fineness of less than 12,000 and specific gravity of 2.9, and chemical properties are given in the table below. Physical and chemical properties of wire meshes are given in the table below, where 8 mm diameter has an yield strength of 520.8 megapascal and 6 mm has 500 megapascal and 2.4 mm welded mesh has 400 megapascal. Mixed design. My target strength is 31.6 Newton per mm square. This mixed design has been tabulated by IS, which has a water cement ratio of 0.45. Hence the mass of the cement calculated as 438 kg per meter cube, and mass of fine aggregate as 711 kg per meter cube, and mass of coarse aggregate as 1072 kg per meter cube, and volume of water as 197 liters per meter cube. Hence the milk proportion for M25 grade of concrete as per IS is 1:1.6:2.5 with a water cement ratio of 0.45. The material used for concrete are cement, sand, coarse aggregate and water. Here the cube size of 150 mm into 150 mm into 150 mm size has been used. Mixing of concrete. The concrete cubes are casted and it has been cured for 7 and 28 days. The cube test is shown here. The compared results are shown here, which has an 7 days average compressive strength of 19.4 for specimen 1 and for 21.6 for specimen 2 and 22.5 for specimen 3, and for 28 days 31.9 megapascal for specimen 1 and 31.2 megapascal for specimen 2 and 33.1 for specimen 3. Here, due to retrofitting by using cement mortar, the cement mortar test has been tested, which is 70.6 into 70.6 into 70.6 mm cube size has been used. The specimen has an average compressive strength of 35, and specimen A1, which is addition of 10% of Alccofine, which has 35.6 megapascal, and specimen 2, which has 37.2 megapascal for specimen 2 and 33 megapascal for specimen 3. The beam design. The breadth of the beam is choose to be 100 mm and the overall depth should be 150 mm and span length of 1000 mm and clear cover of 20 mm. The geometry of the specimen are shown in the figure, which has two numbers of 8 mm diameters at the top and two numbers of 8 mm diameters at the bottom, with two like ties. Casting of concrete beams is shown here. Demolded beam specimen. Testing of concrete beams. The load values of reinforced concrete beams are shown in the figure, which has a total load of 63.6 for specimen 1 and load of 60.5 for specimen 3 and 59.36 for specimen 2 and 58.44 for specimen 4. The crack pattern of RC beams are shown in the figure. The application of welded mesh after the tested specimen. Application of cement mortar for the tested specimen. Retrofitted beam specimen. Testing of retrofitted beam specimen with 10% of Alccofine, 20% of Alccofine and 30% of Alccofine. For specimen 1 with 0% of Alccofine, the load comes to be 110.5 and 10% of Alccofine, the load increases by 119.5, which is almost 120 kilonewton. For specimen 3 it has been 120 kilonewton, and for 30% of Alccofine it comes down of 106.2 kilonewton. When compared to cement mortar it is less. Here is a load deflection curve for the retrofitted beam with cement mortar. Load deflection curve for retrofitted beam with 10% of Alccofine. We can see the increase in the load as the curve goes beyond 120, as same as for 20% of Alccofine, and here the curve comes down for 30% of Alccofine. Here is the tested retrofitted. The initial cracking as for specimen 1 with 0% of Alccofine is 90, and initial cracking for specimen 2, which is 10% of addition of Alccofine, is 95.6, and specimen 3 initial cracking comes to be 100.5, and specimen 4 initial cracking is 93 kilonewton. For ultimate cracking load for specimen 1 is 110.5 kilonewton with 0% of Alccofine, and specimen 2 115.7 with 10% of Alccofine, and specimen 3 119.5 with 20% of Alccofine, and specimen 4 106.2% of Alccofine. Crack pattern for retrofitted beams are shown in the figure, which can be observed. There is a crack at the bottom which is bent in flexure. Conclusions: the beams retrofitted with wire mesh at different stress levels do not debond when the load is on failure. Retrofitted beam corresponding to 10 and 20% has highest load carrying capacity as compared to other specimen, that is cement mortar specimen and 30% addition of Alccofine. After retrofitting, all the specimen showed reduced crack width and large deflection at the ultimate load. When comparing to 0 degree of orientation, 45 degree of orientation of wire meshes shows great distribution of stresses when compared to others. Thank you.